So I will use the time which you give me additionally. I represent here the ASAM EV. I'm officially working for ASAM now 3 years. 20 years before I was working as service provider. And ASAM have at the moment 7 domains. One of the domains which is very popular at the moment is simulation with Open Drive, Open Scenario, Open Label, Open ODD, and so on. But I'm responsible for the other 6 domains, for example, measurement and calibration. There you have standards like MDF, which is a binary file format for storage of data. ASAP2, which is the description of calibration data from classical ECUs. Now it's coming. Other domain is test automation with XIL and OTX. We come later to OTX a little bit. And of course, diagnostic. 10 years ago, I was responsible for the MVCI interface, modular vehicle communication interface, which was also published as ISO standard. And now we have here developed the service-oriented vehicle diagnostic standard. This standard was last year released from ASAM EV. And yesterday I have listened, I think it was in the panel discussion, the question, was it a fast or was it a slow development? We have started this development in 2019. And last year it was released, so it was about 2.5 years, all the time where Corona was available, so only the kickoff meeting and the release meeting was a physical meeting. All the other things was done remotely. But I think it's not a question if it is fast or if it is slow. It was successfully at the end, and it was a development, an really international development with partners from US, from Asia, and of course from Europe. And they have worked all strong together, and I will now present this a little bit. First, the motivation, concepts, method overview. Then I will tell you something about the classic diagnostic adapter and actual activities. I will start with this picture because this picture will show you how it should be understood. What's the goal behind? The goal is the diagnostic for the future. And this future is not restricted anymore, that you want to work with these bytes and bits. Nobody is interested. The people want to have access to diagnostic information, and this diagnostic information comes, of course, from the classical ECUs. But on the other side, I think we have seen in a lot of presentations also today that you have HPCs, the high-performance computer, where you have operating systems, where you have virtual machines, where you have multi-core, and so on. And on this servers, now I will go back, on this servers is running software applications. And you want simple diagnostics, this software applications. And this you cannot anymore describe with these bytes and bits, because you will analyze this software which is running. And because a lot of things are now agile, this software is also exchanged permanently. And then you have new approaches what you have to find out. So you can see the vehicle simply as an IoT device which you want to analyze. And you see here the picture where you have the SOVD server on board. And of course, to avoid any misunderstanding, you can have more as one SOVD server. And that's also very important. ASAM have defined this API, not the implementation of the API. The implementation of the API is in the responsibility of the car manufacturers and the respective suppliers. But here in this picture on space reasons, I have only shown one SOVD server. And here you see, first of all, the classical approach. So you have off-board one tester. It's the SOVD client, which is used for the proximity approach, what you use in the workshop, for example. So this is the classical world, which you have always. Then we have also here an SOVD client inside the car. It's the in-vehicle client, and this have also some advantages, because you must know then all the test software is available in the car and also the hardware. So you are independent from the workshops Of course, if you have the credentials, that's another story. But then you can analyze also from inside the car the functionality of software. And then we have third here, the remote access. And it's important because we will later come to this. You see here the SOVD client is only working with the SOVD server, but you see there is a backend server from the car manufacturer, and for this backend server you can have also this web API. So now we come to the concepts, and because today was in another presentation the question, yes, it's a REST-based approach which works with HTTP 1, and therefore we have, after a long discussion, decided about the overview of the different entities. It's named entities, and in the middle you see the component. A component, you can also name it device, or you can name it a HPC or an ECU, and you see there a recursive approach for subcomponents like an operating system, and so on. And this was a compromise, this entity view, a compromise between a logical view and hierarchical view. This was there done. And the most important thing, for each of these entities, you can define so-called resources, and the resources represent the diagnostic content. And to know how this fits together, we have there, of course, the applications on one hand side, and on the left side you see the areas. The areas are necessary to show how these different components fit together. For example, for a logical view of a software-defined vehicle, or for a domain concept, or for a zone concept. And on the right-hand side you see functions. Functions are functionality which goes over different components and should be presented. And one basic concept of this REST-based approach is that each functionality should only available via one path. And therefore we have defined the resources, and we use simple the crude methods of REST, create, which is named post, the read, which is the get, the update, which is the set, and the delete method. And we have also published the complete API methods as Open API. So the Open API specification is available and can directly used. We use for the data type description JSON, and based on the simple things that we have arrays, structures and multiplexer, you can build up each description which is necessary, how complicated you ever want it, and that's a fact of what is represented by the car. It's not defined from our standard. We have only give the possibility to do this, and the data are described on physical level because nobody is interested anymore in a hex description and once then operate with compute methods. That's all encapsulated, and that's the main goal of this standard. We have also the possibility that we ask, that's a general approach. You have two possibilities. You can have a generic approach, and generic means you do know nothing. You come simple with your mobile device, for example, have the connection to the car, always that you have the credentials, of course, and then you ask, tell me which entities are available, which resources are available, and how the resources look like. You can have on the other side a specific application which is directly written for this car, and this application, of course, knows that there should be a resource with the name. We name it simple speed now, and then they can access the speed and also know the data type description. But in case, and that's a mix, that you do not know how the speech resource looks like, you can ask then, give me please the meta description for the data types of this resource. Yeah, we come now here to a method overview, and I will start on the right-hand side. On the right-hand side, you see the security, and that's also important. ASAM have nothing defined of implementation, and also we have not accessed this security aspects. We have only defined that each service use so-called credentials, and the credentials are in the responsibility of the OEM. In case that the OEM knows what he do, then the credentials are given to the person which should operate with these different resources, and this is the one hand side. And on the other side, you see the capability description. This capability description is once offline available. This is in case that you want to develop a specific application without access to the car, and also it's online available, and you can with the capability discovery ask, like I say, for the different entities and the resources inside. And now we come to the methods. Some of the methods I will show more in detail, but now we are here in the overview part. And of course, the classical fault handling is available. This means you can ask for the fault itself, you can ask for the environment data of the faults, and you can also reset the faults. And here's also one of the basic principles. An access to a resource is always a complete access. So if you have built up a resource which consists of a structure, and in the structure is an array, and in the array is a multiplexer, and the multiplexer is again a structure, and so on, you can do it. But at the end, you have the whole resource with one access, and the data evaluation is then always the task of the consumer. So you can decide at the end, I want only in this structure of the multiplexer this bit or this part of the data evaluate. This is one of the aspects. Then we have the reading and writing of the values. We have, therefore, we distinguish between permanent available data and configuration data. No, the configuration data comes next. The configuration is also possible to set as, this can be, for example, a manifest file or data for variant coding. You can have the access as bulk data or as parameters. So we come now to the operations, and I think therefore I have a special sheet here presented. What can be operations? Operations can be software functions, or it can be I/O data from sensors. Important is that we distinguish between synchronous execution and asynchronous execution. All this information is available, of course, in the capability descriptions, that you know if this operation is a synchronous one or asynchronous one. And in case of an asynchronous one, you have then the possibility, while this asynchronous operation is running, to make a short-term adjustment, to make a freeze, or to make a reset. And also here is important, you know that some of the operations can only be executed in a specific state, and REST itself is stateless, and therefore you have two possibilities. You can explicit in advance, if you know this, to bring the ECU or HPC into the state. And the other elegant way is that we have an implicit mechanism, that we give a so-called hint, and the hint says this ECU must now be in this state, and then the SOVD server is responsible to set the state. Of course, if you do this not, then you will receive an error. This is the live symbol. Also, what is here for all activities possible is that we can have an exclusive lock for these activities to avoid multi-client access from other applications that we guarantee that it is only used for us. So software update, it's also very, and that is something which is totally changed. Also if you compare this with the old diagnostic thinking, where you have flash from blocks and so on, and must know everything, this is all not visible. This is simple, like with a mobile phone. You receive the information, it's update available, and then you will only see here, in this case, for example, an update 1 and the update 4 is available. Then you have the possibility to select if you want to do the update 1 or the update 4. In case that you are more lazy, you select, I take the autonomous one, and the autonomous one here in this case is redirected to the update 1. And then you say only, now I want to do this update. This means the update process is completely encapsulated by the vehicle. And for the update itself, you have also two ways. One way is that we distinguish between prepare and execute. So it's a two-step approach. And the other approach is that we make the so-called automated update, where prepare and execute is running together. And also what is very important, this update process includes everything. This is not only the update, this includes the variant coding if necessary, to set configurations and all the things. This is all encapsulated. And if you remember the hierarchy which you have shown on the beginning, then also if there are entities influenced which below the level where you are, the data for these entities are also completed. So this is something which is completely changed now. This will we not skip, because here you see in the logging we support two formats, and one is the AUTOSAR diagnostic log and trace. And now we come to the classic diagnostic adapter. So why I show you this? Because of we have a lot of existing ECUs in the car, and these ECUs typically communicate with UDS. And one of these things is that here is shown how the UDS commands are mapped to the REST resources. And we have, and this is now the most interesting thing, this is the concept 704, where was the first release in the AUTOSAR last year contained. We had a lot of discussions, very constructive discussions together with AUTOSAR, which was minimum also 1 year running. AUTOSAR was involved in the review of the process, and here you see that the SOVD API handler is now in parallel of the diagnostic manager in compare to this UDS activity. So it was also realized on the AUTOSAR platform. And we will here see also directly in the next steps that in this year release, which is planned, I think also for December this year on the AUTOSAR side, that there are the next activities will come in. And on ASAM side, a new development project is now running, where some use cases which was original lower prioritized are handled. And these are the cyclic repetition of sensor data, trigger-based access, which means first of all you say which of your resources is observable, then you describe with help of the general expression syntax the trigger condition, and third you say if this data which is then available should come in a log file or should directly report it to the client. Important maybe is execution of diagnostic command sequences or custom scripts. This has not the goal to introduce new functionality. The goal is, for example, and you have seen it on the beginning, OTX, Open Test Sequence Exchange format, that such OTX programs can download into the car and then run into the car. And last but not least, we have started a new work item proposal, which is now confirmed that the SOVD standard will be transformed to the ISO. This is a lot of political discussion, but it's now confirmed, and this will be then published as 3 parts. So, and now you have the time to ask questions, and I'm happy to be in time that you will reach your lunch also in time.